Hi everyone, I am Mahmoud Parsipour. In this tutorial, I'll show you how to import decals into Substance Painter, place them on your model, and use a few practical techniques to assign any material you want to different parts of each decal. To get started, let's learn how to import the decals. One way is to click the plus button at the bottom of the shelf, then choose Add Resource and select your .SBSAR files. Alternatively, you can simply drag and drop the files directly into the shelf. All you need to do is select the .SBSAR decal files and drag them into the shelf. The Import Resources window will automatically recognize them as decals and have them ready for import. Next, you can choose where you'd like to import the decals. There are 3 available options. If you choose Current Session, the decals will only be available while this session is open. If you choose Project, the decals will only be available in the current project. And if you choose Library, the decals will be permanently added to your Substance Painter library and will be available in all of your future projects. I'll go with Project and click Import. Once the import is complete, you'll see all of the decals appear in the shelf. They're also automatically filtered using the Imported Resources tag. If you clear this filter, the decals can easily get lost among your other resources, making them harder to find. Since Substance Painter recognizes decals as base materials, you can simply switch to the Materials category to find them more easily. You can also search for them by typing keywords such as decal, hard surface, MPP, or tags specific to each decal, like screw, into the search bar. If you want to see which tags a decal has, simply right-click on it in the shelf, and you'll find all of its tags here. For example, I'll right-click on this decal and notice that it has a tag called Port. Now, if I type Port into the shelf search bar, all of the decals with that tag will be displayed. Now let's see how to place decals on the model. You can do this using either a paint layer or a fill layer, but I personally recommend using a fill layer. Once the decal is placed, you'll be able to move it, scale it, rotate it, and continue editing it at any point throughout your project. I'll drag one of the decals into the Layers panel. Substance Painter will automatically create a fill layer and name it after the decal. I'll scale the decal down in the 2D view. Then, in the Properties panel, I'll set UV Wrap to None so the decal doesn't tile. At this point, I can fine-tune the decal's placement and scale. There's an even faster way to do this. I'll delete the previous layer. Then, drag a decal from the shelf and drop it directly onto the 2D view, exactly where I want it to appear. As you can see, Substance Painter automatically sets UV Wrap to None to prevent the decal from tiling. It also increases the tiling value, making the decal smaller when it's placed, so we can quickly fit it into the area we want. As you've probably noticed, we're placing the decals directly on the UVs. That's why having clean UVs, with UV islands that are as straight and continuous as possible, with minimal distortion, can make the process much easier. However, if we want to place a decal on an area where the UV islands have seams, we can try different projection modes from the Projection section in the Properties panel. I'll search for Panel and place another decal on the model. I'll use Planar Projection as an example, but feel free to experiment with the other projection modes depending on your project and what you need. As you can see, the decal is split because there's a UV seam in this area, but I want it to extend onto the raised section as well. I'll change the projection mode from UV to planar in the Properties panel. As soon as I do that, you'll notice the decal changes both its position and its size. I'll move it back to its original position. Now you can see that the decal is placed on the model without following the UVs. If you look at the back of the model, you'll notice the decal is also being projected onto the backside. To prevent that, simply enable Backface culling in the Properties panel. From here, I can move the decal anywhere on the model without worrying about UV seams getting in the way. I'll move the decal to the top of the model to show you something. scale it up, and adjust its position. However, you'll notice that the decal starts to fade out and disappears around the center of the model. To fix this, I'll disable backface culling again. This allows the projection to continue through the model, so the decal extends onto the backside. Let's place another decal and learn a few more things along the way. I'll type slider into the shelf search bar, then drag and drop this decal into the 2D view to place it on the model. Finally, I'll adjust its position and scale a bit. To open the Properties panel, simply right-click in the viewport, or click this button in the panel on the right. At the top of this panel is the Fill section, which contains the general settings for the fill layer. Below that is the Material section, where our decal is loaded. At the top, you can see all the channels available in the current shader. If you expand the channel mapping dropdown, you'll see that the height channel is automatically mapped to the decal's height channel, while the normal channel is mapped to the decal's normal channel. An alpha channel is also assigned as a mask, limiting the decal to a specific area. If you take a closer look, you'll notice that the decal includes several additional channels. However, since the current shader doesn't support them, they aren't mapped to the shader. Let's add another channel to the shader so we can use it with our decal. To do that, open the Texture Set Settings panel by clicking this button on the right. Then, under the Channels section, click the plus icon and add the Ambient Occlusion channel. Back in the Properties panel, you can see that the Ambient Occlusion channel is now available in the shader. You can already see the effect in the 3D view. Ambient occlusion is especially important for decals because it makes the surface details and depth stand out. If you open the channel mapping dropdown, you'll notice that Substance Painter automatically maps the decal's ambient occlusion channel to the shader's ambient occlusion channel. I'll close the channel mapping dropdown and open the parameters section instead. Then I'll expand the technical parameters group. Here, you can control the 3 channels we've been working with so far. Use normal intensity to increase or decrease the strength of the normal map. You can also switch the normal format between OpenGL and DirectX, depending on your workflow. If needed, you can adjust the height range and height position. However, these settings are only useful in specific situations, so in most cases, you won't need to change them. I'll also leave height blur at its default value. The only time I usually adjust it is when using the height map for displacement and I need softer transitions. Ambient occlusion depth controls the strength of the ambient occlusion effect, making the shadows deeper and more pronounced. Ambient occlusion radius controls how far those shadows spread across the surface. I'll increase the radius a bit so you can see the effect. Let's do the same with the depth. I'll press Ctrl-Z to revert everything back to its original values. Let's go back and check the decal we placed earlier. You might notice that it doesn't have any ambient occlusion. Let's select the decal layer and find out. As you can see, ambient occlusion is still disabled for this decal. That's because we added the ambient occlusion channel after we had already finished working on this decal, and at the time we had a layer above it selected. Substance Painter automatically enables the new channel only for the selected layer and any layers above it, if that channel is available. Going back to the slider decal, you'll notice a few additional parameters at the top of the parameters section. These controls are unique to each decal and may vary depending on the one you're using. For this decal, we have a button move parameter. As I adjust it, you can see the button moving just like a real slider. The next parameter is hole height, which controls the depth of the recessed area around the button. You'll find this parameter on most decals that are designed to sit inside a recessed surface. If I set it to 0, you can see that only the button remains, which can be useful in some situations. Looks like my PC wasn't quite ready for both Substance Painter and screen recording at the same time, so I'll temporarily switch to 2K. The dark outline you're seeing around the button is coming from the ambient occlusion channel. If I disable the ambient occlusion channel, you'll be able to see it more clearly. Since the alpha channel masks the decal, the ambient occlusion is confined to that same area. I'll restore the original values. Next, I can adjust the button height parameter to control how much the button protrudes from the surface. If I lower the value too much, the button starts to look like it's recessed into the hole. The next two parameters control the depth and softness of the button's recess. They give you additional control over the button's shape, allowing you to customize it to fit your needs. I'll set it to 0, and you can see how different the result looks compared to the original. That's the power of procedural decals. You'll also notice a few more parameter groups in this dropdown. We'll cover each of them in detail later when we start assigning materials to our decals. Before moving on, it's worth taking a moment to understand how the normal and height channels work in Substance Painter. From the channel display at the top of the viewport, I'll switch to the height channel. As you can see, it's a grayscale map. If I switch to the normal channel, you'll notice it's a colored normal map that defines the surface details. One thing that makes Substance Painter different is that the height channel is automatically converted into a normal map. You can see the final result in the normal plus height plus mesh channel, where the generated normal information is combined with both the decal's original normal map and the baked mesh normals. If I disable the normal channel, you can still see the normal details in the normal plus height plus mesh channel. That's the normal information generated from the height channel. However, you don't have any direct control over it. If I change the normal intensity in the technical parameters, you'll notice that nothing happens. That's because this parameter only affects the normal channel, not the normal information generated from the height channel. This time, let's disable the height channel and keep the normal channel enabled. Now you can see that the normal intensity is fully controllable. You'll also notice that the decal has a cleaner, higher quality appearance. Now I'll enable both channels again so you can better see the difference and understand what I've been explaining. As you can see, the height channel behaves a little differently than the normal channel. It always generates dark edge details to represent height transitions. While this can be useful, it can also make the decal look less natural, especially when the decal is very small. For small decals, I usually recommend relying only on the normal channel with a higher normal intensity. This often produces a cleaner and more natural result. That doesn't mean the height channel is unnecessary. There are actually several reasons why it's still important. The first reason is exactly what I just showed you, the unique edge details it creates, which can be useful depending on the type of decal. The second reason is that the height map can be used for displacement and alpha workflows in other applications. And I'll explain the third reason later when we start using decals with generators. Now it's time to learn how to assign materials to different parts of a decal. I've already added a few decals and materials to the Layers panel, including a background layer and several decals. I've also added a few material layers above them, including both regular fill layers and folder-based materials, such as Smart Materials. Traditionally, if we wanted to apply a material to specific parts of a model, like the corners of this object, we would first add a black mask to the material. Then, we'd add a paint layer inside the mask. Then, using the polygon fill tool, such as the UV chunk fill mode, we would start selecting the areas where we wanted the material to appear. We'd simply click on each UV island until all the desired parts of the model were selected. However, if we try to do the same thing with decals and create masks for their different parts, you'll quickly notice that it isn't possible. I'll add another paint layer inside the mask and look for a way to isolate different parts of the decal. But you'll quickly notice that it isn't possible. That's because decals aren't part of the mesh itself. They're actually material layers projected onto the model. I'll select one of the decals and show you an alternative approach. Back in the Properties panel, under the Parameters section, you'll notice several additional parameter groups that control other channels. The first one is the Color ID channel. It allows us to assign different ID colors to different parts of the decal, making it easy to isolate and mask those areas later. However, our current shader doesn't include a color ID channel, so there's nothing we can map the decal's color ID channel to. So first, we need to add a color ID channel to the shader. To do that, I'll open the Texture Set Settings panel, click the plus button, and look for a color ID channel or one with a similar name. Since there isn't a dedicated color ID channel, I'll choose one of the user channels instead. I'll rename it to Color ID. Set its color space to sRGB and enable it as a color channel. Now the shader has a color ID channel that we can map the decal's color ID channel to. If I switch the channel display to this channel, you can see that it's working exactly as expected. This approach works perfectly fine, but if you look at the channels available in the shader, you'll notice that we now have two color channels, base color and color ID. Since these decals don't contain any base color information, that channel is already in use. So I'll remove the color ID channel from the shader. Then I'll enable the base color channel on the decal and map the decal's color ID channel to it instead. This gives us a few advantages. Now we can also see the color ID information directly on the material because it is being mapped through the base color channel. However, this black color means that no valid color ID has been assigned yet. To fix this, I'll go to the decal parameters and open the channel color ID group. Here, you'll find several predefined masks that are already set up, each with a default red color. I've already chosen the materials for these parts. For these two buttons, I'll use this simple orange plastic material. For these two buttons, I'll use this simple gray plastic material. And for the middle button, I'll use this simple black plastic material. All the remaining parts will keep using the base material. Now I'll try the masks one by one until I get the result I'm looking for. The first mask affects the entire decal, which is not what I want. The second mask affects the area underneath the buttons, which is also not what I'm looking for at the moment. The next mask is the first button I need. I'll keep it with its default color. This mask is for the next button. Since I want its material to be different from the previous one, I'll assign it a new color, for example, green. And I'll copy this color ID value because I need another button to use the same material. I'll enable the next mask, and since this button needs a different material, I'll give it a new color, like blue. The next mask belongs to the button that I want to have the same material as the second button, so I'll assign it the same green color value that I copied earlier. Keep in mind that for the color ID setup, any parts that are supposed to have the same material need to use the exact same color value. And the last mask is for the final button. The default red color already matches, so we're done. Now, if we switch to the base color channel, everything looks correct. However, since the background material has a green color, it can sometimes cause issues. That's why at this stage, I always use a black material for the background and disable the other materials, so we have a clean color ID map with a black background and separate colors for masking. Now I'll go to one of the materials and add a color selection filter, which is designed in Substance Painter to convert color IDs into black and white masks. I'll use it to create the masks I need and finish the setup. However, there is one problem. Unfortunately, this feature only works with color textures. There is no option to directly use individual color channels as a mask source. If this feature existed, or if we could use anchor points for this purpose, everything would be much easier. The color ID workflow would become much more powerful and much faster than the current method. Hopefully, Substance Painter will add this capability in future versions. That's why we need to export a base color texture here, so we can use it in the next steps. Now I'll go to the Export Textures section. I'll set a path to save the exported textures, Choose the metal roughness template and set the file type to PNG with 16-bit depth. I'll keep the resolution at 4K to get a high-quality texture. In this section, since we only need the base color map, I'll keep only that option enabled and disable all the other outputs. Click the Export button and close this window. Now we need to import the texture we just exported back into Substance Painter so we can use it. Simply drag and drop it into the shelf. Keep in mind that since color selection can only work with textures, we need to set this option to texture before importing it into the project. With this setup, our Color ID texture is added to the shelf and can now be used by other tools and features inside Substance Painter. Now I'll return to color selection, find the base color texture from here, and select it as ID mask. Before using the texture and picking the colors, I'll go back to the decal layer and disable the base color channel, because we no longer need it and it could still affect the final material color. Now, by clicking on Pick Color, the texture will automatically load in both the 3D and 2D views, and we can start selecting the colors we need. Since this selection is for the black material mask, I'll pick the blue color. For the gray material layer, I'll add a black mask and then add a color selection. I'll assign the texture to the ID mask slot and then pick the green color. I'll repeat the same process for the orange material layer. I'll add a black mask, add a color selection, select the texture, and this time pick the red color. If you notice that one of the masks doesn't fully cover the area you want, you can increase the tolerance value to get a better result. However, be careful when increasing this value, because it will start selecting similar colors as well. At higher values, it may even include colors that don't look similar to you. As you can see, this method is quite simple. In short, we need to create a color ID map, export its texture, and import it back into Substance Painter. Then, by using Add Color Selection on each material layer, we can generate the masks we need. Now, let's see where this method really shines. As you can see, I've created a unified color ID setup for all the decals we have on the model. Now imagine doing this separately for each decal. We would have to repeat the same steps multiple times and create extra textures and mask layers. To do this, we only need to assign a unique color to each material. Also, to make it easier to remember which color belongs to each material, we can set the material layer color to something close to its assigned color ID. As you can see, I've assigned the red color to every area where I want the metal material to be applied. I've also used yellow for the glass material. I used green, cyan, and blue for the plastic materials, representing the orange, gray, and black plastic variations respectively. Finally, I assigned magenta as the color ID for the rubber material. And that's all I had to do. It only took a few minutes. Then, just like before, I set the background to black, exported the base color map, and imported it back into Substance Painter. Now we no longer need to see the color IDs. So I'll disable the base color channel on all the decal layers, so those colors won't appear in the base color anymore. Now let's move on to the materials. From this point on, the process is very simple. We just need to enable the material layer, add a black mask, and then add a color selection. In the color selection settings, instead of using the baked texture, we'll load our exported base color texture and simply use the color picker to select the color we assigned to that material. As you can see, I'm repeating the same process for all the material layers. The only thing that changes is the color I pick, based on the color I've assigned to each layer. Without any additional work, each material is automatically placed exactly where I defined it earlier in the color ID map. As you've learned, the color ID workflow is very simple, but when you're working with a large number of decals on a model, it can dramatically speed up the entire process. The biggest limitation of this workflow is that once the materials have been assigned, moving a decal or using any of its procedural controls, such as the button position slider, will cause the material to become detached. The decal will move, but the material mask will stay in its original position. I'll make this decal a little smaller and move it around so you can see exactly what I mean. As you can see, the materials stay in their original positions because their masks aren't dynamically linked to the decal. The reason is that color selection is using a static color texture to generate the masks. There's no quick way to update that texture, so every time you make this kind of change, you'd have to repeat the entire process from the beginning. So if you decide to use this workflow, I recommend making sure you're completely happy with the decal placement and layout first, and only then start assigning the materials. Now I'll remove all the color selection filters from the material layers because I want to show you a more flexible workflow. I call this workflow the blending mask workflow because we'll be using a channel with the same name in Substance Painter. To get started, I'll select a simple decal, like this slider. Then I'll open its Properties panel. In the Parameters section, just below the Channel Color ID group, you'll find another group called Channel Mask. Just like before, the first step is creating a channel in the shader where we can map the decal mask channel and use its data throughout our workflow. We'll go to Texture Set Settings, click the plus button in the Channel section, and under the Unsupported by Shader category, add the Blending Mask channel to the shader. Now we go back to the Decal Properties panel. As you can see, a new channel called Mask has been added, and it has been automatically enabled. I'll open the Channel Mapping dropdown, and as you can see, Substance has also automatically mapped the Decal Mask channel to the Shader Blending Mask channel. After that, I'll scroll down. Since our mask channel, just like the Color ID channel, needs some initial setup, we have to configure it first. Once you expand this group, you'll see some parameters at the top that allow you to make some adjustments to the channel. For now, we'll skip explaining these options. Below that, you'll find several other parameters that, just like the Color ID channel, allow you to enable or disable the mask for different parts of a decal. Let's take a look at the Color ID channel. We previously assigned a cyan color to Color Mask 03 so we could apply the button material to that area. Now, to use the mask channel and apply the material to the same area, we need to enable Mask 03 in the mask channel. After this, our mask channel will be ready to use as a mask in the black mask of our material layers. Now I add a fill layer to the black mask of this layer, and I want to use the mask channel available in this decal in the grayscale section. To make this work, we need to create a connection between the decal and the fill layer. In Substance Painter, this connection is created using an anchor point. I'll right-click on the decal layer and add an anchor point, because the channels are stored directly in the layer itself, not in the mask. An anchor point with the same name as the layer will be created automatically. Now, when we go back to the fill layer, you'll see that the anchor point section is now available, and the anchor point from our decal layer can be selected here. After this step, the channels from the decal layer are now available in the fill layer. However, we need to specify the correct one from the reference channel section. In this case, we need to select the blending mask channel. And exactly the same area that we enabled in the mask settings has now received the material. Let's quickly try this workflow on a more detailed decal as well. Let's open this decal settings. As you can see, the mask channel is automatically enabled here as well, and the correct mask channel has already been mapped. As mentioned earlier, in this workflow, we can use the Color ID channel as a guide to see which masks need to be enabled in the mask channel. In this Color ID, the green color represents the two buttons that I want to assign the same material to. Now we need to enable the same masks in the mask channel, mask 03 and mask 07. Then, we add an anchor point to the decal layer. Then, we add a black mask to the desired material layer and create a fill layer inside it. Next, in its settings, we click on Grayscale, go to the Anchor Point tab, and select the anchor point from the current decal. Then, we set the reference channel to Blending Mask. Our material is now applied exactly where we expected it to be. But I want to assign another material to these two buttons as well, for example, this gray material. First, I'll add a fill layer to the mask of this layer to show you the problem. I'll follow the same steps and select the blending mask from the decal layer. As you can see, the new material is applied on top of the previous one because both materials are using the same mask. Since changing the mask settings and enabling other buttons would still result in the same mask being used for both materials, we need to find a way to create a new mask inside the blending mask channel. Since we have already used the mask channel on this layer, we need a new layer that only contains the mask channel. By configuring it again, we can create a new mask. First, we duplicate the decal layer and rename the original layer so we can identify it clearly. We don't need to make any changes to the original layer. However, in the duplicated layer, we disable all channels to prevent them from affecting the material and keep only the mask channel active. Then, as before, we enable the corresponding masks in the mask channel for the areas where we want to apply the second material. Since the anchor point was also duplicated with the layer, we delete it and create a new anchor point on this layer. Then, in the material layer, we go to the fill layer inside the black mask and select the anchor point from this new decal layer. This allows us to use the new mask we created instead of the previous one. Now, the original decal layer contains all the decal channels and the mask for the first material, while the second layer only controls the mask for the second material. At this point, you can already notice the biggest weakness of this workflow. Although it solves the main limitation of the color ID method and allows us to move the material together with the decal, the process is still slow. Since Substance Painter does not allow us to move both layers at the same time, every time we move or transform the decal, we have to apply the exact same changes to the duplicated layers as well, so the other materials move to the correct position. Now imagine having a large number of multi-material decals and deciding to edit them after the material work is already finished. But don't worry, this is not our final solution for decal material creation. The reason I introduced this workflow is to show that, despite its limitation, it is still very useful for decals where we only need to assign a single material to a specific part. These types of decals, such as screws, buttons, and the slider we used at the beginning, are very common in our projects. Alright, now let's move on to the third method and explore the most powerful workflow in this tutorial. In the blending mask workflow, we saw that this method works very well for decals that only use a single material. The reason is that we only had one mask channel inside the decal layer, which could control the mask for one material, but not more than that. So, if we create enough mask channels in the shader based on the number of materials needed for each decal, we can solve this limitation. We go to the texture set settings and add the first mask channel, the same blending mask channel we used before. Since this channel can only define one material, I'll assign it to this orange material. So, if we want to add a gray material for the other two buttons, we need to add a user channel. I'll rename it to something like M1 and set it to L8 to create an 8-bit grayscale channel, just like the blending mask channel. Now, if you open the decal settings, you can see the difference between a blending mask and a user channel. The blending mask is automatically enabled on the decal layer after creating it in the shader, and it is also automatically mapped to the decal's mask channel. However, with user channels, we have to do both of these steps manually every time. Keep this in mind, because sometimes you may think everything is set up correctly, but the masks are not working properly. In most cases, the problem is that the shader channel has not been mapped to the corresponding decal channel. Now, let's set up our masks. Since the mask channel was already configured in the previous workflow, the first mask is already set up correctly and affects these two buttons. However, for mask 1, we need to enable the masks for these two buttons. Since we already identified them earlier, we know they are mask 04 and mask 06. If we are not sure, we can use the color ID channel as a reference. Now, we have two separate mask channels inside the same decal layer, each controlling a different material. To use these masks, we follow the same process as before. First, we add an anchor point to the decal layer. Then, on the material layer, we create a black mask and add a fill layer as a sublayer. In the Fill Layer settings, under the Grayscale section, we go to the Anchor Point tab and select the desired decal layer's anchor point. Finally, from the reference channel, we choose the specific mask channel we want to use. I'll repeat the same steps for the second material, but this time I'll use the M1 mask channel as the reference. Now, let's add one more material. This time, I want to assign a black material to the middle button. So, we need to create a new mask for this material. First, we add another user channel to the shader, name it M2, and set it to L8. Then, in the decal layer, we enable this channel and map it to mask 2 so we can use it as a separate material mask. Now, in the Parameters section, under the Channel Mask 2 group, we need to enable the mask corresponding to the middle button. To make sure we select the correct one, we can check the Color ID channel. As you can see, the correct mask is Mask 05, which we previously assigned the blue color in Color ID. After that, we follow the same steps as before, adding a fill layer, selecting the anchor point of the decal layer, and finally choosing the M2 channel as the reference channel. This workflow overcomes the limitations of the previous two workflows. After the decal material setup, the decal can easily be moved around on the model while keeping all the materials connected, making this workflow very flexible. Even if you change the projection method, for example, from UV projection to planar projection, the materials will still remain perfectly aligned in the correct places. At this point, we have 3 mask channels in our shader. This means we can use this workflow for any decal that requires up to 3 different materials using this shader. If we need decals with more materials, we simply have to add more mask channels to the shader. We call this workflow multi-masking because it uses multiple mask channels to control different materials. Now imagine you've already textured a decal in one project, and later you want to reuse the same decal with all of its materials in other projects. To do that, we'll start by creating a new folder in the Layers panel. Then, we place the desired decal, along with all of its associated materials, inside the same folder. Next, we give the folder a name. I'll use a simple one, but it's a good idea to choose something more meaningful. Make sure the layers are organized correctly inside the folder, with the decal layer placed below all the material layers. After that, we right-click on the folder and select Create Smart Material from the menu. This gives us a reusable Smart Decal, just like a smart material that we can use in other projects whenever we need it. To demonstrate it, I'll remove the other layers and bring the Smart Decal back into the project. In just a few seconds, we have a fully textured decal ready to use, and we can move it anywhere on the model without having to set everything up again. This can be incredibly useful and can save you a lot of time. There is one important detail we need to keep in mind. Let me open a new project to show you. In the new project, we search for the decal in the Smart Materials shelf and add it to the project. The Smart Decal is imported correctly, along with all of its material layers. However, the materials are not displayed on the decal. This happens because the custom mask channels we added to the shader are not available in the shader of the new project. Once we add the first mask channel, the blending mask, you'll see that the first material is applied to the decal correctly. Let me move the decal to a different location so we can see it more clearly in the 3D viewport. Notice that the materials still move together with the decal. Now, if we add our second channel, User 0, the second material immediately appears in the correct place. After that, we can simply rename it and set it to L8. Let's finish by adding the third channel. If you remember, it was User 1 in the previous shader. This time, though, I'll deliberately choose a different user channel to show you what happens. As you can see, just like the previous two materials, the black material doesn't appear on the decal either. Let's open the decal settings and find out why. Because this channel wasn't part of the original decal setup, the decal doesn't recognize it. That's why it's disabled by default. If we enable it, you'll see that it's mapped to the wrong channel. Also, if we open the fill layer that drives the black materials mask, you'll notice that the reference channel is set to not mapped. This means it still can't find User 1 to establish the connection. Fortunately, the fix is very straightforward. After enabling the new channel, we only need to correct the mappings. We map mask 2, the channel used by the third material, to User 7. Then we open the corresponding fill layer and set its reference channel to User 7 as well. To avoid running into this issue in future projects, it's a good idea to establish a consistent convention for your Smart Decals by always using the same shader channels in the same order. Or, if needed, you can simply correct the mappings using the method I just demonstrated. So far, we've learned different ways to create the masks we need. Since many materials rely on generators, we also need to introduce our decals to them. Because decals aren't part of the mesh, generators can't detect them automatically. To get started, I've already placed the knob and slider button decals on the model. I've also prepared a simple background material. It consists of a basic base material with a second, slightly brighter material layered on top. The upper material has a slightly negative height value and is masked using the fiberglass edge wear generator. The second material is built in the same way. It's a very simple setup that uses the metal edge wear generator to drive its mask. We'll apply the metal material to the knob and slider button, while the background material remains on the rest of the model. Let's start with the knob. As we learned in the previous part, to access a layer's channels, we first need to create an anchor point for that layer. Next, we need to open the settings of the generator that we want to take the decal into account. Then, locate the Micro Details section and enable Micro Height. Now, simply click on the Micro Height input. Using the decal's anchor point, select the decal you want to use, then set the reference channel to the decal's height channel. Now the generator treats the decal just like any other piece of 3D geometry. To achieve the result you're looking for, you can fine-tune these parameters in the Micro Details section. And that's all there is to it. Adding decals to generators is that simple. Now it's time to apply the metal material to the knob. To do that, we'll mask this area using one of the 3 workflows we covered earlier. Since this decal only requires a single material, I'll use the blending mask workflow. Since this channel isn't available in the current shader, we first need to add it. As we mentioned earlier, Substance automatically enables it and maps it to the corresponding decal channel. Now, using a fill layer inside the black mask, go to the Anchor Point tab, select the decal's anchor point, and set this channel as the reference channel. The reason the material was applied to the correct area is that I had already configured the mask channel for this decal. As you can see, this decal only has 2 mask channels. The first one is used for the entire decal, while the second one is assigned to the knob. As you can see, the metal edge wear generator isn't affecting the decal yet because we haven't linked the decal to it. To do that, we'll follow exactly the same process as before. First, enable micro height in the generator settings. Then, using the decal's anchor point, assign the decal's height channel as the micro height source for this generator. Then, adjust the curvature intensity, height details intensity, AO radius, and AO depth parameters in the micro details section until you achieve the result you're looking for. Because our background material uses a negative height value, that height information is also being picked up by the material above, which isn't what we want. There are several ways to fix this. To prevent any of the underlying materials channels from affecting the material above, I'll use masks once again. I'll add a black mask to the background material, repeat the same workflow as before, and reuse the mask we created earlier. Let's switch to the mask channel in the display channel view so it's easier to see what's happening. Here we can see the current mask. What I actually need is the exact opposite of this mask. To do that, I'll add a filter on top of the fill layer and select the invert filter. Now, wherever the mask is black, the background material is no longer applied. If we switch back to the material display, you can see that we've achieved exactly the result we were looking for. Now, let's do the same thing for the second decal. First, add an anchor point to it. Then, go back to the first generator and add this decal's height channel as its micro height source. However, the micro height input in this generator is already being used by the knob decal, and each generator only supports a single micro height input. To solve this, we'll simply duplicate the generator. Then, in the duplicated generator, clear the micro height input and, just like before, assign the slider decal's height channel as its micro height source. As you can see, the generator is now affecting the slider decal. However, it no longer affects the knob decal. Even though we now have 2 generators, and each one works correctly on its own, the problem most likely comes from the way their masks are being combined. Let's switch back to the mask channel in the display channel view. As you can see, the first mask is gone because the second one is using the default normal blending mode. To preserve the white values from both masks, we can change the blending mode to max lighten. Likewise, if you ever need to combine the black values from multiple masks, you can use min darken. These 2 blending modes are extremely useful whenever you need to combine masks. Now, let's apply the metal material to the slider button. Since the blending mask channel is already set up in the shader, and this decal already has an anchor point, all we need to do is add a fill layer to the material's mask and follow the same steps to create the mask. Since I had already configured the correct mask channel for this decal, the material was applied to the correct area immediately. This is where you can see the difference between using the blending mask channel directly and using the other mask channels. Even though this mask is still using the default normal blending mode, the issue we had before doesn't happen here. Just to be safe, I'll set the top mask's blending mode to max lighten. Now we need to link the decal to the second generator as well, so the edges of the slider button also receive the edge wear effect. We'll follow the same workflow as before. Duplicate the generator, then use the anchor point to assign the slider decal's height channel to the micro height input. Now, to make sure the masks from both generators blend together correctly, simply set the upper generator's blending mode to max lighten. Also, to make sure the unwanted channels from the lower material do not affect this area, we'll use the same method as before. We'll place its mask inside a fill layer and keep it below the invert filter so the filter is applied to this mask as well. So, that's everything we need for texturing a decal. The main steps are creating masks and, when needed, introducing the decal's height channel to the generators. After that, it's mostly about repeating these workflows and using your creativity and previous experience to achieve the result you want. As you've seen, we introduced the decal to the generators using micro height by assigning the decal's height channel as the input. We can also use micro normal instead, but there are a few important differences. To better demonstrate the difference, I've placed 2 identical decals and 2 identical dirt generators on the top material layer. In the first dirt generator, I'm using micro height for the button on the left. As you can see, all the micro detail parameters remain fully adjustable, giving us full control over how the dirt appears, and the dirt effect is generated correctly on the decal. For the button on the right, I'm using micro normal in the second dirt generator. As soon as I enable it, you'll immediately notice the difference. To do this, simply enable micro normal instead of micro height, then assign the decal's normal channel to its input. As you adjust the parameters, you'll notice that the height detail intensity parameter no longer has any effect. Also, increasing the AO parameters creates unwanted artifacts around the decal, and the overall dirt quality is nowhere near as good as what we get with micro height. If you remember, we talked earlier about why it's important to have both the height and normal channels. This is one of the biggest reasons why the height channel is still essential, even when a normal map is available. However, simply having a height channel isn't enough. It also needs to be enabled in order to be used by the generators. If you don't want the height effect to be visible on the decal, or if the extra surface detail it adds is getting in the way, simply reduce its opacity in the Layers panel. This reduces the height channel's influence on the material while preserving its full effect in the generators. This way, the normal channel is used for displaying the decal, giving you better visual control, while the height channel is reserved for the generators, allowing both to work independently without conflicting with each other. If you remember, we skipped a few parameters above the mask channels earlier. Now let's quickly go through them. As you can see, I've already defined 3 mask channels in the shader. I've enabled them for this decal and mapped them, in order, to mask, mask 1, and mask 2. In the mask channel settings, I've enabled the mask for the knob. If you remember, all we had to do was use this mask in the fill layer inside the material's mask, and the material was applied to the knob correctly. I've reserved this channel for the base material. But we also have a yellow material on a specific part of the decal, and we don't have a mask for it yet. Let's start by looking at the first fill layer to see how this mask was created. As you can see, this fill layer is using the blending mask as its reference. That means it's using the decal's mask channel, the one that covers the entire knob, so the yellow material is applied across the whole knob. The second fill layer, however, uses M1, which is mapped to the decal's mask 1 channel. This creates the smaller circle inside the knob. The third fill layer uses M2, which is mapped to the decal's mask 2 channel. It defines an even smaller circle, which is subtracted from the second fill layer using the subtract blending mode, giving us this final material layout on the knob. Now let's go back to the decal layer and take a look at how these two additional masks were created. In the Mask 01 settings, you can see that I used the knob mask and resized it using the shrink/grow parameter until it matched the size I wanted. As the name suggests, this parameter lets you grow or shrink all active masks in this channel at the same time. The corner type parameter controls how the mask expands or contracts. Since we're working with a circular mask here, I've set it to round to preserve its shape. The Mask 2 settings are exactly the same, except I've increased the shrink value so the third circle fits inside the second one. I've also set the corner type to round to preserve the circular shape. But this time, let's set the corner type to angular. Although it's mainly intended for masks with sharp corners, it can also be used with circular masks. If I reduce the smoothing value, you can clearly see how this corner type turns the circle into an angular shape. Now, if I increase the smoothing value again, you can see exactly what this parameter does. It's used to soften sharp edges and corners. By adjusting these parameters, you can get different results. Finally, the blur parameter lets us soften the edges a little. This is especially useful when the material has some height, as it helps create smoother edge transitions. Let me add a little positive or negative height to the yellow material so you can see the result. Another way to do this would have been to paint the material directly onto the knob. But because we used the decal's own mask channels with the multi-masking workflow, we can now move the decal freely or even turn it into a smart decal without losing the material setup. Now, the last remaining section in the decal settings is Edit Masks. If you open it, you'll notice that it contains almost the same parameters we learned to use when editing the mask channels. The difference is that these parameters are no longer tied to a specific mask channel. Instead, they let you edit the decal's original masks directly. Their main purpose is to help you fine-tune the mask if you feel it isn't perfectly aligned with the part it's supposed to cover. By slightly expanding or shrinking it, you can fix small alignment issues and make the material fit the decal as accurately as possible. You probably won't need to use these settings very often, but they're there whenever you need them. Now, let me show you a small issue that's actually more of a bug in substance. When you place a decal on the model using a fill layer, you may occasionally run into a small display issue. It happens more often if you rotate the decal first and then start scaling it. As you can see, the decal doesn't display correctly, and it almost looks like the normal map has been flipped. This happens because the fill layer is using a negative tiling value. To fix it, simply open the Properties panel and remove the minus sign from the tiling value. Other than this, most issues are related to layer order and how different channels blend together in the Layers panel. This isn't just important when working with decals, it's a fundamental part of working in Substance Painter. Once you understand it well, you'll be able to solve almost any issue that comes up with ease. However, since decals mainly rely on 3 key channels, normal, height, and AO, all we really need to do is control these channels and how they blend with the corresponding channels in other layers. Fortunately, Substance Painter gives us plenty of blending modes to make this much easier to control. And if those still aren't enough, as I showed you earlier, you can always use masks to completely block a layer's channels from affecting the layers above, so they don't need to blend together at all. Thank you so much for watching this video all the way to the end. My goal wasn't just to show you how to use decals as quickly as possible. Instead, I wanted to focus on the concepts behind them and solve the common problems step by step, so you could better understand both how decals work and how Substance Painter behaves. I hope I was able to achieve that. I also hope these decals will be useful in your own projects and help you add details to your models much more quickly. Finally, I'd like to mention that this video was translated and dubbed using AI. If you notice any issues with the English voiceover or subtitles, I sincerely apologize and thank you for your understanding. See you later.